Hi, so for this video what we're going to do is we're going to look at setting up the FX5U PLC to control a variable speed drive. In this case we're using the ABB ACS 380 VFD, and we're going to exercise this control using Modbus communications. Okay, so we're going to set it up to send signals to control the start stop and the speed and the direction. Okay. So we're not going to get too deep into the Modbus protocol here, but we're just going to go through the physical setup, so the wiring of it, the FX5 setup, and the parameters and the code function that we use, and then on the drive itself, we need to set up the drive, the parameters on the drive for the Modbus communication as well. Okay, so the first thing that we can look at is the physical wiring. So on the FX5 CPU, which is on the left hand side here, we're going to use one pair of wiring, so it's just a pair of twisted pair of wire to handle the Modbus communication. All right, and you can see here that we have send A and receive A, they're tied together, send B, receive B, tied together. That's out through our twisted pair, and this is the terminal setup on the VFD. Okay, so it is a 485 port that we're using on it. Okay, you'll note just on the drawing here, you'll see that the A channel on the PLC connected through the black cable goes to the B channel on the inverter drive. This is a little quirk sometimes with Modbus communications where the A and B can be mixed like that. If it's available, what you're really looking to see is the polarity, so the positive and the negative. So the positive terminal here is connected to the positive here, and the negative is connected to the negative here. Okay, and then the other cable that we have in here is just a ground, okay, a shield cable. We can show you just briefly on the actual PLC itself. Okay, so the 485 port on the FX5 is just this one over here. So you can see I've got some looped cables here. For I think green I have on A, blue I have on B, and then I just have a ground shield cable there on that. I'll show you the ports on the VFD in a second, just when we get down there. Actually, we can just finish off with the PLC what I have here in the setup at the moment. So just on the panel, the rig that I have here. So I've got the FX5 PLC. It's the one on the left here that we're going to be talking to, and then we just have some inputs and control lamps here, just to see the status of it. So for the VFD setup itself, then we have got the terminals just down here. Okay, so there's our terminals just over here on the right. So we've got our A, B, our ground, and our shield for the RS485. So we've those set up as well. Okay. The other thing that you'll see on the wiring setup here is our termination resistors. All right, so there's a little switch that we have set on the PLC to give us the 110 ohms here for the two-wire communications. And then on the VFD, there's these little jumpers that we have to set. So on the VFD itself, it shows you the jumpers and it shows you the pattern for each one. So obviously I have only two devices here, so each of them needs a termination resistor. If I had more than two devices on the network, then the first and last one need the termination resistors. The intermediate ones don't. Okay, so just while we're there, you can see there's the jumpers there. I know the image is a little bit blurred there, but that's the jumper setup here then. Okay, and it just gives you just a little map on the left of that there, just to show you the setup as well. Okay, I'm just going to come back up here to the VFD screen itself then, because we'll be doing a little bit of work on that. So I have the inverter drive set up here, just connected to a three-phase motor there in the background that you'll be able to see as well. Okay, so that's our physical wiring setup. Okay, and I suppose that's one of the first things to get out of the way, is to set that up and understand your communications from that point of view. Okay, so the next thing we're going to look at then is just setting up the PLC parameters, so that this allows us to exercise the Modbus communication. Okay, so for Modbus, we go into our parameter list here, the FX5 CPU parameters, module parameters, and then it's that 485 serial port. We're setting up the communications for that. Okay, so first thing, we just go to the actual GXWorks file here. So I have a program here. I'll talk you through the program in a minute. Okay, but just on the GX Works here, if I go down here to the 485 serial communications and open that up, so communications protocol type up here. There's a drop down here for the different types of protocols. So we want to select Modbus RTU communication. I suppose I should have clarified earlier. It's Modbus RTU we're using, not TCP. But so it's Modbus RTU that we're using here. So we click on that, and then in the advanced setting here, then we set up our communications settings. So the baud rate, the parity bit, and the stop bit. Okay. They obviously have to match between the PLC and the VFD. This is the default stuff on the particular variable frequency drive. Okay, so I've just matched that on the PLC. You can go into the VFD parameters and change those in the parameters if you want to in there as well. Okay, so you can match back this way. So once we've that set up, then I have a couple of other ones highlighted here: the Modbus device settings and the latch settings here, the FX compatibility. We don't actually need to worry about those for a moment. It's just that the Modbus communications up here that we need to set. Okay, so that's the PLC side of things. Now there is the command and the programming in here that we're going to look at, but we'll have a look at that in a minute. Okay. On the VFD side of things, to set it up for Modbus communication, so the ABB use what they call macros. So the macros are just, they will go in and they'll set up certain parameters to default settings for you for different settings on the VFD. Okay, so these are the control macros here. So you have input output control, you have field bus control, standard 2-wire, and there's an alternative 2-wire one that they have, but the one we want here is the Modbus RTU. Now it sets it up as an AC500. That's an ABB PLC, but this will give us our Modbus RTU communications. Okay, and you can see the default stuff for it here. So the node address, the baud rate, and the parity. So I didn't show you that setup on the PLC. So the PLC is going to be the master in this system, so it's node 0, and then obviously again I only have one device on it, so the VFD will be node 1. It's the default on it. When you go into the Modbus RTU, again you can go into the parameters and set different node addresses on that then if you need to. Okay, but just on the VFD then I'll just show you how to get in and set up the Modbus RTU. I just turn that camera slightly, it's just going to get the screen as clear as I can on it. So the first thing is it's in remote control here, so to get out of that I just go back. Okay, back. That puts me in local mode, and then I can go into the menu over here, and then down to the I/O menu, click OK on that. So this is the current macro that's selected, so we just press OK on that and it brings it into the selection screen where we can select the different macros, and we're just going to arrow down until we get to Modbus RTU and then click OK. Right, and that'll load up that macro then to the system. Alright, and you can see here it's giving you the baud rate, the node, the parity. Sorry, let's see if I can get that a little bit clearer for you. 1 second. Not quite getting there, but so the baud rate, what we're seeing in the baud rate there is 3. Oh, there you go now. Okay, so you're seeing 3 in the baud rate there. Okay, that 3 is when you go into the settings, there's options 0, 1, 2, 3, 4. 3 is setting it up for the 119.2 kilobits. Okay, so we can just click the back button there then until we go to the main screen. Alright, and then just to put it back into remote control, which is allowed the PLC to be in control of it. So local is just I can use the start stop here on the screen. Remote is anytime I want something else to be controlling it. Alright, so there's a couple of things we can see there on it. Let me just get a bit closer to it there. You might be able to see them a bit better. Okay, so the top left hand corner we have remote mode. The right hand corner we have the set speed in there at the moment. We'll come back and talk more about that at the moment, or in a minute. The center is the direction of rotation, so it's a forward rotation at the moment. The dead center of the screen, then those numbers, is the actual speed, and it's in hertz at the moment. Okay, so with that we'll see that update as we run the motor as well. Okay, so that's the setup on the VFD side. So now we've set both of them to be able to communicate to each other. Okay, and they should talk to each other. The next thing we want to talk about then is just a little bit on the Modbus and how it's set up to work between the PLC and the VFD. Okay, so the first thing on the PLC, the FX5 PLCs, these are the function codes. So we know Modbus operates using function codes. We use these codes to tell whether we're writing to a register, reading from a register, setting coils, or just reading inputs, whatever we want to do. Okay, so these are the options we have available. The ones we're going to be using are the 03H and the 10H there. So we're going to be reading the registers and writing registers. So the ABB inverter drive that I have here, that stores all its information in registers. All right, so we're just going to be reading some registers and writing to the registers, and I'll explain each of the registers and which ones we're interested in as well. Okay, so in this case, it's going to just be reading registers and writing registers is what we want to do. And this is the actual program function in the FX5 PLC then. So it's ADPRW is the one for the Modbus communication, and this is the layout for it in the ladder diagram editor. This is the layout diagram for it in the function block diagram editor. Okay, and you can see here that it's got source 1, 2, 3, 4, then source 5 or destination 1, and then destination 2. So this is our little descriptor here of what each of those pieces of information are there. So source 1 is the slave node address. So that is what device do we want to talk to. S2 is the function code. So what do we want to do? So that's the functions we just looked at on the previous one here. So are we reading or writing, or what are we doing? Source 3 then is the actual device we want to read. Okay, so which register do we want to read? 4 is how many registers do we want to read or write to. Okay, and then 5, the S5D1 is if I'm reading, it's going to store it in D1. If I'm reading, it's going to store it in S5. If I'm writing, it's going to take the information from D1. And then D2 then is a communications control. Okay, so we'll talk a little bit more about that there in a second. But let's just have a look at if we pull the code out here and give you an example, right? So it's ADPRW, and then these are the names of each of the devices here. So as an example here, so we've H1. So if I put H, so for the slave node and the function code, we have to use hexadecimal numbering. So that's the H is coming in there. Okay. For the address and the count, we use decimal numbers. So that's the K. All right. So H1 is slave host 1. So we're looking to talk to slave 1, device 1. Okay. H3 here then, if you remember, up here is to read a holding register. So that's what we're doing. We're going to be reading registers here. And it does say registers because we can read multiple at a time. All right. And then K3 is that we're going to start at register 3. So for this particular example, I want to start at register number 3 on whatever device this is. I'm not particularly talking about the ACS380 here. So we're going to start at register 3. The count here, the K1 is, I just want to read one register. So all I want to read is register number 3 in this case. Okay, and then I'm going to save that information that I get from that register into data register 100 on the PLC. Okay. Then this communication status. So we have an M coil here on the communication status. So when we put that M coil in there, it ties in 3 coils, 3 consecutive coils. Okay. So the M100 will be active while the communication is working. So that'll be high while the communication is working. M101 will go high when the communication is complete and there is no error in the communication. And M102 will be active when the communication is complete and there is an error. All right, so that's our little communication error flag as such. All right, the M101, I'm going to see it in the program here, we can use that to say, right, that communication is done, shut it off, and we'll move on to the next thing that we want to do. Okay, so you're not keeping that communications tied high to this particular function all the time. Okay, so that's the setup on the PLC side of things. And I'll just, in the code here, I'll just show it to you real quick. So here we're going to be using 2 of these commands. Okay, so one is the H3 we just looked at, that's going to read, and the other one is a H10 that's going to write to registers. All right, so that's essentially how we communicate with the VFD here. It's just those 2 commands. One is reading and one is writing. Okay, and we'll get into the information we're reading and writing there in a minute. Okay. So that's the PLC setup side. So we have the command here. We want to read or we want to write, and we tell it what registers we want to read to and stuff like that, or write from. Okay, sorry, read from or write to. Okay, so on the VFD side of things, then, so on the drive side, what are these registers? So for the ACS 380 Modbus, these are the registers. All right, so 40,001 is the control word. So what it's using is it's using this register here, and each bit in the register has a function to control the drive. All right, so these are each of the bits within that register. Okay, so the bit 0 is to run stop. Okay, these other ones here all have different bits and pieces. Bit A here, or bit 10, is the field bus control. Okay, we have these ones, the ramp control here. So 4 will, if that goes to 0, right, it's the ramp out 0. But if that goes to 0, that bit goes to 0, then the drive will stop. The same with 6, the drive will stop. 5, I keep clicking on, sorry. 5 will prevent the ramp from changing. So even if I change the speed on the VFD, if 5 is low, it won't actually write that new one to the drive, and it'll just hold it. Okay. So we'll look at this in a little bit more detail as well in a minute. All right. So that's register 40001. All right. 2 is a default, so it's reference 1 here is a default. Okay. On that default is a speed. So that default reference 1 there is speed 1. So there's default reference 1 and 2, 02 and 03 there. They're two separate speeds we can set if we want to. So we can switch and say, right, use reference 1 or use reference 2. All right. So in the words here, we can turn them on and turn them off. Okay. Sorry, you see it just down here. Run at speed 1 or run at speed 2. Okay. 04 then is the status word. So 1 is the control word where we can set things to turn things on and off from the drive, and 4 is the status word where we see what is the status of the drive. And again, each bit in there has a function. All right, so ready to switch on, ready to run, tripped, switch on inhibited, warning, at set point. Okay, so there's all of those little bits in there that tell us what's happening with the drive that we can use. Okay. 5 then is the actual value 1. All right, so that's a default actual value 1. That is the default setting there is the speed. Okay, so what's the actual speed of the drive? So up here in the control 1, sorry, up here in 02 we can set a speed, and then down here in 05 we can read the actual speed the drive is running at. All right, now when we read those registers, they read as counts. Right, so they have a count value in the register. That count value, if we divide the value we see in the register by 400, that gives us the reference in hertz. So 1 hertz is 400 counts. All right, so if we want to see the frequency that it's running at, we divide by 400. We'll see that in the PLC program where we've done that as well. Okay, and 06 then is the actual value too, so a second speed value or second value, we might put current in there or something like that. Okay, all of these, as you can see, this default here. When we set that Modbus RTU macro, we set all these to these default values. Right? If we want to change that, right? So if I don't want reference 2 to be a second speed, I want it to be something else, I can go in here to this this parameter here on the drive, and I can set that to something else then. Okay, so we can change these ourselves as we go if we want to. Okay, the other registers then just to mention them down here, we have data in and out, but down here the last ones down here is where we can have the parameters, so that there's a couple of hundred parameters that we can set for the speed drive. We can set them individually in here. Okay, so for instance, as I said, the reference to default here is a second speed. It's in parameter 58102. So I can go in here and I can directly access that, and I can change it down here if I wanted then to set it to something else. Okay. So that's how the Modbus is sharing information with us. It's storing it in those registers, or we can input into those registers. Okay. So the control word up here is a read-write register. All right, because we can read what's in the control word at the moment, and we can write to it to update it. Okay, the same with these are read writes. The status register is a read only because the status of the drive is set by the drive, and then we read that register. And the same with these actual values here, then they're read only ones as well. Okay. As I said, that lays out the control bit there. And this one here then, so we have the VFD registers over here that we just looked at. Okay, so 01 is the control, 02 is the speed set 1, etc. Okay, in the program that I have in the PLC that we're going to go through in a second, what I'm doing is I'm going to read this register and I'm going to map it to data register 100. So when I want to look at what's in the control word on the VFD at the moment, I'm going to be looking at data register 100. Okay, I'm going to use data register 200 for information I want to write to the register, so to that control word. Okay, so I'm going to use 200 to write, and I'm going to use 100 just to read to see what's coming back. Okay, the same for the speed sets here. I'm going to use 201 to write, 101 to read, or what it's at the moment. You can see here for the status word that it's in 04. I'm putting it into 103. And I don't have a write here because remember that's one of the read-only ones, and the actual speeds here are read-only as well. Okay. Now, as I said, the actual speed when we read that back, so if I look at 104 here, when the actual speed comes back in from the VSD, it's going to come in as a number of counts. Okay, I need to divide that by 400 to give me the hertz. So again, we'll see it in the program. I take 104 here, I divide by 400, and I store that value into D330, and that will give me this actual speed in hertz. Okay. When I want to set the speed, I'm using D400 here. So I'm going to put a value into D400 in hertz. Okay. And again, we'll see it in the program. That value I put in hertz in D400 gets multiplied by 400 and then sent to D201. So I can set a speed then, because again, that counts as what I need to send to the PLC to control the speed. Okay. So that's kind of the setup that we have here, and there is a lot of movement and information moving between registers, and having your documentation all nice and clean and clear is important for this. Okay. So just to go back here for a second, again, as I said, these are my two commands here. I have the H3 here, which is reading registers, and the H10, which is writing registers. Okay, so just the reading registers one here. Okay, the information that I have in here, so H1, H3, K0, K5, D100, M100. Let's just look at that here for a moment. Okay, so what do we have there? So it's ADPRW. So this command is a read write. So we don't have to tell it we're reading or writing in the command. We do that in the function code over here. Okay. So again, slave node H1. So I'm talking to host 1, my VFD. H3 is I want to read the holding registers. Okay. I want to start at register 0. So the register in the VFD is ID'd as 400001. Okay. But that's register 0. Right? So when I want to talk or look at that register, from the PLC point of view, I'm looking at register 0. Okay, so that's why it's K0 in there and not the 4001. All right, and that's why I have that VFD register number here. So the actual address of the register in the VFD is this, but the number of that register is 0. So that's register 0, register 1, 2, 3, 4, 5. Right, and that's the value we put in here. Right, so I'm starting at register 0, which is 400001. And then the K5 in here is I want to read 5 registers. Okay, so I'm going to read 01, 02, 03, 04, and 05. I want to read all 5 of those registers at the same time. Okay, the store then, I'm going to take the information from those 5 registers and I'm going to start and I'm going to put it into D100. So what that means is that 01 will go to D100, 02 will go to D101, 03 will go to D102, 04 will go to D103, 05 will go to D104. All right, so that's the way I've set it up. So if I want to look at what's in the control word, I look at D100. If I want to look at speed set 2, or speed set 1, sorry, I look at 101. All right, so that's where I'm storing the information on the PLC. Okay. And again, then with the communications, M100 is high while the communication is happening, and then when the communication completes without an error, I get M101. They're the two I'm looking at. I'm hoping not to get an M102 because that's the error in the communication. Okay, so that's the setup here for my read. All right, then the next thing I want to do then, next command I have here is my write. Okay, so I'm reading 5 registers so I can read all the information that's in there. I'm only writing to 2 registers. I'm writing to the control word so that I can change the status and I can move, turn on and turn it off and forward reverse. And I'm sending the speed. I'm writing the speed as well that I wanted to run at. Okay, so that second function then, the write to registers one, again, H1, we want to talk to the host one. H10 is that I want to write holding registers. So that goes back to our setup here. Oops. This one. So H10 here, write multiple registers. Right, so these codes are Modbus standard codes. So the H10, there's a standard Modbus code. We're going to start at register 0 again. So remember, that's the control word, 01. And then we're going to write 2 registers this time. So 01 and 02. If I put 2 in here, it's going to be 2 consecutive ones. I can't pick and choose. If I need to register 01 and 04, but not the ones in the middle, then I'd need 2 separate write functions for that. Okay. So I'm going to write 2 registers, and the information is going to be in D200, and that's what I want to send to the VDF. So D200 will have the status word, and I'll send that to the VDF, the VFD, sorry, and D202, sorry, that should be 201. Oops. Let me come back to that there now. That should be 201 there is going to go to 402. All right. And again, 200 is my M coil for this here. So 200 active while I'm communicating, 201 active if it communicates without an error. Again, that's the key one I'm looking for. Okay, so just again, let's have a look at them over here. So that's that one there. Okay. Now, I can't do the read and the write at the same time. I have to separate my communications. All right. So to do that, what I'm doing here in the program is I'm using M1 to control that. All right. So just mcoil M1. This is my communication control. So if M1 is low, I'll do the read, and if M1 is high, I'll do the write. Okay. And I'm toggling that then by this M101. So remember, this is my read communication finished without an error. So if that goes high, if I finish that communication without an error, I'm setting M1. So that'll turn on M1. It'll stop this communication, turn on this communication. Then I do the write to the VFD. And then if the write is successful, 201 here will go high. And I'll reset M1. So I'll turn off this comm and I'll turn back on this comm, and we'll do it again. So they'll just keep swapping over and over and over. Okay. Just doing the comms, sending, receiving, reading, sending, reading, sending, reading, just over and back. Okay. So this piece here on the program is really that communications control. Okay. The read, the write, and then how am I controlling which one is active. All right. Just above that, the very first line that I have up there, that's an SM402. So remember, that's our initialization coil, or the first run high. What that's doing is it's just sending a number into data register 200. So you can see it's sending this K value here into data register 200. Okay. I have this other file here that I'll show you. Okay, so this other file, oops, sorry. What we have in the other file here is I have the control word, okay, and I have the status word. I have each bit mapped out here, so 15 all the way back over here to 0. Okay, or if I do this sheet here, I have this one updated properly. Yeah. So it's actually 0 all the way to F, because they are the bits for the PLC. Each bit in the register is identified by its hexadecimal bit. Okay, so 0 to 9 and then A to F. Okay, so you can see here that I have, when I have it set ready to run, okay, these are the status of the bits. So these are all zeros. This is a 1 because it's my field bus control. These are 1s because I want to allow it to ramp. All right, and these are 1s here, so I'm not stopping it. Okay, so a 0 here would inhibit the operation. A 0 here would do an emergency stop. We'll have a look at that in a minute. And a 0 here does a stop as well. Okay, so that's the bits, the binary setup of my register. Okay, and what I have here to the right, just to help me out here, is I can take all of these binary values here, and I'm just, on this one here, I'm just doing a binary to decimal. Okay, so it's taking all these binary setups and it's giving me the decimal number, so 1150, and that's the decimal number I'm sending here into the register just at the start so that I can set up my register. So my register is set up with this line here, so I have all of these set up with the bits, the right bits in the right places. Okay, I also have the hexadecimal version of it here, so I can send it either the binary or the hexadecimal. So I could do, instead of move K1150, I could move H47E, I think it was it? Yeah, 47E for stop. Okay. If I want to run, then I could move 1151 in, because I just changed this bit to make it run, or I could 47F if I want to do the hexadecimal. Okay. What I've done in my program here, is instead of writing numbers each time, all right, I'm just changing individual bits that I want to change. All right. So instead of writing 1150 and 1151, I'm just going to set and reset bit 0. Okay, so to make it run, if you come down here with me, my motor start here sets D200 bit 0. My motor stop sets D200, or sorry, resets bit 200 dot 0. So I'm just turning on and off that bit individually in the data register. Okay, so I'll press start. This bit goes to 1, and then the communication is continuously happening, so that gets sent over to the VSD. Okay, so that's how I'm controlling my start and stop. I just here, so my start stop is just in these two here. So just on the start, I have a start button, and then this one here, if you remember the control register, sorry, the status register, okay, bit 7 in the status register is a warning. So if the VFD goes into warning, okay, that bit goes high. So I'm just preventing me from starting the motor if there's a warning or an error on the VFD. That's all I'm doing there. Okay, I have my stop stopping here, and I have my e-stop just taking that bit low as well. So the e-stop, when I press it, I'm changing the emergency stop bit on the VFD, so that changes the ramp profile of how it slows down. But I'm also just sending the stop bit as well. I just want to make I don't want it to restart when I clear that. Okay, so that's my start stop control. This is my emergency stop. As I said, I'm setting D200.2. So if we go back here, and we go up here to my control word bits, D200.2 is off control 2, and that is an emergency stop. Okay, that's the way it's set up for this particular one here. You can see it's emergency stop there for bit 2. Okay, I should say you have a couple of tabs down here, right? Depending on the version of the inverter drive that you have, the bits within the control word and the status word are different. Okay, so you need to know the version of firmware that you have on your drive, and obviously for different drives and different control manufacturers and stuff, that will be different as well. Okay, so this is specifically for this particular drive and this version. Okay, so that was my e-stop. What else we got down here? So this one here is my forward reverse. Okay, so I have a button here. Okay, that if I press the button, I'm going to alternate M10, so it'll go high or low. And if M10 is low, I'm going to go forward, and if M10 is high, I'm going to go reverse. Okay, so for this particular version and this particular model, there isn't a bit for forward reverse. So on some of them, you'd expect one of the bits here to be forward reverse. Okay, not in this one. In this one, it's the number that we send. Okay, so for forward we send a positive number, and for reverse we send a negative number. So remember I said I put in the hertz into D400, and then we multiply that by 400 to get the counts, and it's the counts we send to the speed drive. So here, if I multiply by 400, I'll send that to the speed drive. If I want to reverse, I'll multiply it by minus 400 and I'll send a negative number, and that'll just reverse the direction then. Okay, so it's the plus minus that creates the direction rather than a bit that's doing it. Okay, the other thing I just have up here then for my speed change, or sorry, my direction change, my forward reverse, is I have this one in here. So this one I'm saying that D101, okay, that's the data register I'm taking in the actual speed of the motor from into. Okay, and I'm just saying here that that has to be 0. So I want the actual speed to be 0 before I'm allowed to change between forward and reverse, so that the drive itself would allow me to go straight from forward to reverse. It would deramp forward and ramp in reverse. But I'm just saying I don't want to do that. I want it to be stopped before I can go to reverse. Okay, so that's that piece there. And then this one, this line of code here, is taking in the actual speed from the VFD. It's multiplying it by 400, or sorry, dividing it by 400 to give me the actual speed in hertz, so I can read in what speed is it actually doing in hertz. Okay. Just a couple more, and then sorry, just light controls I have down here then. So these ones here are just status lights. Okay. So for the status lights, I have a red light for stop, a green light for running, and a yellow light then for starting. So it's when it's in the ramping phase. So I've started it, but it's ramping either up or down. Okay. And these status bits that I'm using here, okay, again, they come from the control or the status word. Okay. So which ones have we got here? We've got .1 and .8. Okay, so .1 is ready to run. So when I tell it to run, that'll go high, and then .8 here is at set point. Right. So if it's not ready to run and it's not at the set point, we have a red light for stopped. Right. If it's ready to run and it's at the set point, we have a green light to say it's running. And if it's ready to run and not at the set point, then it must be ramping. So that's when we have the yellow light. Okay, and it can be ramping up or ramping down. Okay. This piece here then on the red light is just, I have my warning here. So that's the indication that the VSD has a warning. So if I don't have a warning, I have a solid red light. If I do have a warning, I'll use the 1 second clock here to pulse the red light. Okay. I'll get a warning when I do an emergency stop on this, so we'll see that then. Okay. X4 is a fault reset. All right, so this is if the VSD goes into fault. I can press X4. I can set that in the control word that resets the fault. So just in the control word here, .7 is a fault reset. So I'm setting that high just to reset the fault in the VSD. And then finally down the bottom here, I'm just using X5. This is allowing me to change speed. So in the registers that we have here, we could have two different speeds in here. Okay. And we can swap between them to say which speed we run. I'm just doing it through the program here. So what I'm saying here is if X5 is high, I'm going to put 20 into the hertz register. Okay, and if X5 is low, I'm going to put 40 in there. So I'm using the same speed set. I'm just changing the value in the speed set 1. I'm changing the value in there to change the speed for me. Okay, so that's pretty much my setup. I have the key protagonists over here on the right hand side in the watch window that we can have a look at as well. I've already downloaded the program to the PLC, so I'm just going to put it into monitor here and we'll start watching over here. Okay, and you'll see straight away the activity here. So that M1 is going high and low. So you can see when it's true, the top ones are working, and when it's false, the bottom ones are working. Okay, and it's that 100 and 101 for the read and 200, 201 for the write. They're the ones I want those to be toggling all the time. All right, that the O2s are the error ones. I don't want to be seeing those. Okay. So the other thing that I have set up down here is I have a D100 here. So this is my control word that I'm reading from the VSD. Okay, and I've set it up to read it here in binary, so I can see which bits are high and which bits are low, and that then I can take back to the map here and I can put into the map. So if something's not right, I can have a look here, see which bits are high and low, bring it back here, put it into the map here, and that'll give me a number and stuff, and I can go look up codes and figure out and see which bits are high and low here. Okay, so I could see, oh wait, hold on, fault is off here, or speed inhibited or something like that. Okay, and I have the same for the status here as well. All right, and then this is the one I'm setting. So this is the control word that I want to send. So these two should match. Okay, except for a split second after I change something down here before it sends. Okay. 400 is where I can put in the speed I wanted to run at in hertz. So you can see here I've got it in 40 hertz. And remember what I said, we are going to multiply that by, sorry, 40 is in there. We're going to multiply it by 400. Okay, and that goes in here to the speed set then. So this is the actual speed we're sending to the drive. Okay, and then this one here, sorry, that's the set speed, the actual speed there. 104 is the actual speed coming back, and the actual hertz then when we divide that by 400. So you can see it's doing 0 at the moment. Okay. So we're gonna try popping the window left here, and we'll put the camera on here then as well. Alright, so we're just gonna try and make this thing run. So we're gonna try a start here. Alright, so the speed is at 40 here. That 40 could be from the last time I ran it, so we'll see. But if I hit start here, and my start goes high, you can see it ramps up. Okay, the ramp up, ramp down speed, you can set that as well. You can set that in parameters. Okay. So we can see it's running. You can see we get the 40 here is the set. This is the actual hertz. We get the direction of rotation. And we can see the 40 has come back here as the actual speed as well. Alright, and if I just hit the stop button, we'll see it deramp. You can see the numbers dropping here as it deramps, and this should be matching over here pretty much. Okay. Now if I want to change direction, alright, so the forward reverse here is X3. So I'm going to press it on over here on the real thing, and we should see things change. Okay. Oh, we've got an error. Okay, because I didn't press X3. I pressed the emergency stop. Right, so the error has cleared itself because I released it. So sorry, X3 here. I hit the right one this time. That's my forward reverse. So you see, I still have 40 hertz in here, but I'm multiplying by minus 400. So the set speed I'm going to send is minus 1600. Okay, so if we watch here, let me just see if I can get that a little bit clearer there for you. Okay, when I hit run, okay, you can see it's just a minus 40 in here. You see that there, and it's going to a minus here. Okay, and then we'll just stop it. Okay, and we'll do the X3 here. So when we do the X3 here, we'll see that the hertz goes, just that minus disappears every time we change that X3. Okay, so there it is, minus. Okay, every time it goes high, it just changes. So there's plus, right? And that just gives us our direction. So if we just go minus again for once more, and we're going to start, you can see, sorry, just a change of direction here on this as well, and the motor changes direction. Okay. And I just turn that off, and then so X2 here is my emergency stop. So I'm just going to hit the emergency stop here. So hit the emergency stop. You see I've got a warning up on the drive. Okay. You can see, actually I don't have the lights on this. Let me put the lights in here. Y0, Y1, Y2, and Y3. Actually we don't need it Y3, and Y0 is wrong. So we don't need Y3 here. So you can see the red light's flashing. It's going true false there because I've got the warning. Okay, if I turn off the e-stop, it just takes a second, but it'll clear the warning itself then because that e-stop is gone. So you can see it's true because it's fully stopped now. Right, and when I do the start here, you can see the amber goes high until it gets up to speed, and then we get the green one. Okay. The display here seems to be slightly lagging. Okay. We just stop. Again, the amber will go through while we're stopping because we're deramping. It deramped pretty quick there, so it's gone to red straight away. Okay. What else do we have? Oh, yeah, change the speed then. So we're going to again, we'll hit the start button up here. We get it running. We're running at 40 hertz, and then X5 is the one that changes my speed. So when it's low, we're at 40, and when it goes high, we change to 20. So you see the 20 changing here. Go straight to 20, and then we ramp to that. Okay, we're still in reverse. Now I'm going to try. See, I'm just up here forward reverse. I'm going to take that through, but you can see it's not reversing for me, or not going forward for me because it's running. So I have to stop it. All right, when my register gets down to 0 here, okay, that's when I can change the direction. Okay, and then I can start it in the opposite direction then. Okay, and again, this one sets the speed either direction. Okay, so I can have my 2 speeds there for my variable speeds for loading and unloading or whatever that might be. Okay. Right, let's stop that. Alright, we'll go full screen back with this guy just for a second again. So that's the setup. So we looked at the physical wiring of it and making sure that we have our cable set up and our termination resistors in there. We looked at setting up the FX5 parameters so that we can do the Modbus control, setting up the macro control on the VSD, so it'll do the Modbus communications, the communications function itself, that ADPRW, for sending and receiving the Modbus communications, and then what information we actually want to swap. So how is the information stored on the drive, where is it stored on the drive, and where can we put that onto the PLC, and then trying to interpret some of that. And then a bit of a program here then just to show us some of the control we can have on the motor. So start, stop, forward, reverse, and an e-stop as well on it, and multiple speeds. Okay, so that pretty much covers everything we wanted to have a look at for this one. Thanks.